Welcome back, guys. After all this theory part right now, let's have a look into some practical exercises. Let's see how we can hook an NDK method. On the first time, we're doing it the easy way. And there's absolutely no reason to go for a hard way if there is such an easy way like this one over here. So while we are doing this over here, you might really think that I'm trolling you, but I do not want to spoiler too much. Therefore, let's have a look into this one. Okay, so here we are back at Ubuntu VM, and now let's have a look into this application. So you can find this as an attachment of this section over here. And it's named, let's see, Frida NDK. Alright, and let's install this application. So we get back our smartphone screen over here. There we have it. And then let's copy this application into a new directory first. So within apps, Frida NDK. All right, now we open this in a new terminal and we perform our ADB install on this one. Let's have a look into this. Here we have it. So you can see I play a lot around with different colors in my applications, and this is really what I like. All right, let's open this one, and here we can see this time I really did play around, maybe a little bit too much, but nevertheless, we have a look into the function, not at the design right now. We've got this text over here, Udemy app hacking, and if we click crypt, then we can see it appears over here. So this is the crypted text. Okay, now let's change this text over here. In this one, let's say Frida is awesome. We hit the crypt button, and we can see the decrypted text over here also changes. Nice. Let's have a look into this application. So we reverse engineer this application right now. Therefore, we go into apps on Frida NDK, and we're opening this one with JDX GUI. Okay, first look into the Android manifest. This one over here, we can see we've got an internet permission. Okay, and then we can see only one activity. And otherwise, nothing fancy in there. We can see over here we're having a lib, or many libs. So over here we've got a lot of compatible libraries. We've got 64-bit support, we've got 32-bit support for ARM, we've got x86 and 64 for our virtual machine. And right now we are working on a real device. And this one over here, this is the ARM 64-bit, this version, libnative-libso. This is the shared object file, the library that gets loaded into our application. Where? I guess within the main activity. Let's have a look. Yes, so here we have it. Here we have the static context, system load library, and then we've got this native lib. All right. We can also see we've got a native function over here, decrypt string. So this one is taking a parameter, a string parameter, and an integer value. I guess that's exactly the same function we have already analyzed, the source code regarding to this application on the slides. All right, this means this one over here, this is our parameter. So let's see where this is being called. Over here, and it's being called with this password, this one over here, and with the value 4. So these are our rounds. Okay, if you now want to have a look into this function, this is unfortunately not that easy, because this one is being included in our library, in this libnative-libso. This means even if you click on this one over here, it's not defined in our Java code. So we would have to reverse engineer this one over here, but that's ARM assembler. This is a whole topic on itself, and this is something we cannot cover right now in this course over here. I will prepare another course for this one, but for now on, we will be absolutely fine if we are able to hook this function, to see what are these values, these parameters, to play around with these values, and also to observe the return value. Let's have a look how we could do this. So we put this on the right. We open our Visual Studio Code project over here. All right, now a new file, and let's see. Okay, so I have told you if you want to hook or observe a native method, we have to do it with the interceptor attach. This one over here. And let's first change to JavaScript. Interceptor.attach. Then we've got our two parameters, the native function pointer and our callbacks. Whoops, there's a problem. Never mind, I guess yes. Screen copy did disconnect, but we can forget this right now. Maybe let's put this on the left. Okay. So this is how we can hook native functions, but this is the hard way. So this is the hard way. Now's the question, what is the easy way then? Well, if you take a look into this one, we can simply hook the Java function. So there's absolutely no reason in this application to hook the native function over here. The native function is being defined in this library, and what we need to do is we need to get this function address, then we have to provide our callbacks, and then we can observe the parameters and return values. We will do this in the next video. But over here, it's absolutely enough if you're just hooking the Java function. I mean, this is exactly the same. We are calling this function on the Java side, we make our transition into the C++ side, and then backwards. It's absolutely enough to only hook the Java side. And now you might ask yourself the question, why are we even learning this? Why do we learn how to hook a native function with the interceptor attached? The reason for this is not all functions we want to hook are defined in the Java world. For example, let's assume we've got a function only written in C++. And this function is performing some stuff in this library, but it never leaves this library. This will also mean that we do not have to define a function in our Java code and prototype for this function, and this means we cannot hook this in our Java world. Alright? Maybe not, but we will find this out in some further sections. For now on, if we are dealing with a native function that has a prototype in the Java world, we go the easy way. And the easy way is the way we already know. So let's get rid of this one. Go away. We want to have the easy way. Okay. What do we need to do? I mean, this is simply just a class method. So therefore, let's get the class reference. Let's define a new implementation for this one. And then let's see what are the parameters, what's the return value, and let's play around with this one. Alrighty? Amazing. Let's do this. So therefore, we are back to java.perform. We've got our anonymous function. And here we now need to get the class reference of the main activity. So main activity, java.use, package name, appending the A which has not been copied, and taking the class. Alright, now we're having this class reference. This method has been defined in this class, and therefore we can now also access it. So we are using this main activity, and then this method name, and we want to define a new implementation. We provide this anonymous function. We've gotten parameter 1, we've gotten parameter 2, whoops. And now we simply want to print them out. And param1 is equals, let me put this on the right, param1, and param2 is equals param2. Now we can also check the return value. So our return value is this one. Maybe let's store this in a variable. Let's see, we have to get this object from the original. So we need to call the original method, therefore this dot decrypt string. Then we need to provide our two parameters. And now we're having here our return value. Whoops, that's not a bracket. Okay. Now we can also print out the return value. And now we can also return back this return value. All right, and now we have done everything. Okay, regarding to printing this out. So we are printing out those two parameters of this function. Then we are fetching the original return value in a variable that we can print it out. And we can also return back the original value which has been here, which has been returned back from this method over here, the original method. Alrighty? Okay, let's see. We get back our smartphone screen. Here we have it. And then we need to start our Frida server. Data local temp, Frida. All right, this is running in the background. Then we need to attach to this process. Frida-u, we can find this package identifier in the Android manifest. Oh, we still got it here. Let's see. Com app hacking NDK Frida. All right. Com app hacking NDK Frida. Now we are attached. Let's apply our script. Okay, and let's simply hook this one over here. Let's see. I make this a little bit larger. Okay, I guess that's good. And now I'm clicking crypt in 3, 2, 1. There we go. We've got payload 1. This is our text. All right, this is the text that's being provided over here. This is our payload 2. This is the integer value. And this one is the text that's being returned. Perfect. We have hooked an NDK function in Frida. Okay, this one, I mean, that's the easy way because we are having a prototype and function definition in our Java world over here. Then we have easy access. And please, if you're having this easy access, there's absolutely no reason to go on the hard way for this one. All right? The only reason to go on this hard way is flexing in some kind of report. So if you provide a report to the customer, then you might want to flex over there and show all your skills you've got right now. But if you're doing this in a reverse engineering approach or to test an application, absolutely no reason for doing this. Alrighty? Okay. Now let's manipulate these values a little bit. So let's see. I mean, this one over here, this is an amount of round. Maybe let's set this number to 1. Let's see what happens regarding to the output. This one is now a little bit annoying for me. Therefore, let's save this into a script and then, we are just saving this one and updating our Frida instance. So we save this in apps, Frida NDK, flexing on native methods, JS. All right, and now let's close this one here and load it with the script. Within apps, Frida NDK, flexing on native methods. All right. Now let's get back our smartphone screen, which has disappeared once again. This one is a little bit rough to get it out. Okay, here we have it. All right, and just a little bit. Okay. So here we have it back. Let's see, we hit crypt. Oh, this one over here has changed. So the amount of rounds seems to affect our output. And do we have a feeling in which way does it affect? I mean, something is recognizable. So if you're taking a look at these two spaces, we can see these are now being represented with this exclamation mark. And this might also happen for other letters. Let's see. At least I cannot see anything. All right. We can now do some kind of analysis. And for example, we could put this a little bit down. And then we can and we can change this one to 2. Let's keep this in foreground. We save this and we hit crypt once again. Okay, so it changes a little bit again. Therefore, we are having now these two characters. 3, save, button, once again. Okay, there seems to be some pattern. Let's do some negative value. All right, crypt. Once again, we've got some non-printable ASCII characters, it looks like. Okay, let's provide the number 0. We've got back our output. This is one of the most basic cryptographic examples you will find out there. This is the Caesar cipher. If you're having a fixed value, for example, the number 13, it might be also known as rod 13. So this is just a rotation based on the numbers of rounds we are providing over here. For example, the number 13 will rotate every character in our letter by 13 values. So for example, A becomes, let's see, I'm not sure, rod 13. Let's only do the capital A. Oh, I have to save it. Okay, now we can do it. A becomes N and so on. Let's do it this way. Yes, and so here we have it. Alrighty? Alright, so this is all for this video right now. We have seen if we've gotten function definition in our Java code over here, in this one, then we can easily hook this method, even if it's an NDK. Within our Java world, absolutely easy. But nevertheless, we will also do the NDK approach within the next sections. The reason for this is we need to be familiar with this one, also on a training example like this one over here to get into this topic, because afterwards we are doing some complex hooking. We are hooking native functions that are only defined in this native library, so they do not have an external access over here in our Java world. And this would mean that we are not able to hook them easily like we have seen this over here. So if this function has been only defined in this native library, then we do not have this Java approach over here, and we need to be familiar on how to do this, because then we can also solve really complex challenges in just a few minutes. Alrighty? Okay, so I'm looking forward to see you in the next one where we talk about the hard way. See you there.